Welcome to Pomodoro Joe for Friday, August 18th, 2023. Today we're doing LeetCode problem 1615, Maximal Network Rank. This is a medium problem. There is an infrastructure of n cities with some number of roads connecting these cities. Each road's index I is equal to A sub I, B sub I, indicates that there is a bidirectional road between cities A and B. The network rank of two different cities is defined as the total number of directly connected roads to either city. If a road is directly connected to both cities, it is only counted once. The maximal network rank of the infrastructure is the maximum network rank of all pairs of different cities. Given integer n and the array roads, return the maximal network rank of the entire infrastructure. All right, and then we have some examples. So, this is clearly a graph problem. We have nodes and we have connections between those nodes and they're bidirectional. That doesn't really matter because in this case, we're not actually traversing any of these nodes. We don't need to traverse this graph. But we do need to know how many nodes are connected to each city. So basically what we'll do, we'll go through, we'll find out how many roads connect to each city. So we'll transform this roads list into something a little bit more usable. In this case, I'll use a dictionary, but basically we just want to have some way of saying, given a city, A, how many roads are connected to that city? Then once we have every city mapped to the number of connected roads, then we can just go through all the pairs. So every pair of city will find the connected road count. Now it will be a little bit tricky because we do need to check to see if those two cities are connected themselves, but that's not that bad. Then once we find the maximum network rank, we can return our return value. All right, so let's put 25 minutes on the Pomodoro timer and we will get started. So first, let's just have some result and we'll set it to 0 to start and we will return our result at the end. Next, let's transform this list of roads into something a little bit more useful. So in my case, I want some way of just given a city to find out how many connected roads there are to that city. So I think the simplest thing is to use a dictionary. And in our case, I'll actually use a default dictionary of sets. So the dictionary will map a city or a city name to a set of all the connected cities. So let's have a default dictionary here, and I'll just call this the graph. All right, this will be a default dictionary. And it will be a default dictionary of set. So the default dictionary is just a standard dictionary, but I don't need to initialize it if I don't have a value for a given key. It will just have a default value of an empty set. All right, so then for every A and B, so that's every city A and city B in our roads list, well, we'll just add this to our graph. So our graph for city A will add city B. And the graph for city B will add A. So now we have a graph where if we pass in a city or if we index using a city name, we'll get the list of all the cities that that city is connected to. So that's essentially the count or the list of roads. All right, next down here, we'll just go through every pair of city. So we can call this A and B, but yeah, I guess we'll call it A. So for every city A, no, I don't think I will do city. Okay, let's do this. So this doesn't actually tell us that the cities are named from 1 to n or from 0 to n. We can probably make that assumption. Let me actually check down here. Yeah, this doesn't actually tell us. Oh, I see. A and B are somewhere between 0 and n minus 1. Okay. So the city names actually are between 0 and n minus 1. So let's see. That means we can actually just go for every city A in range of n, and then for every city B in range. And we will start at A plus 1, so we'll start at the next city. We don't have to redo all the cities that we've done before, and we'll go up to n. Now at this point, we need to calculate this network rank. Let's see, what do they call it here? Yeah, network rank. So let's just create a function for this. Let's just get the rank. So we'll have rank is equal to network rank for cities. Now I don't have this function, but we'll make it. And we'll just pass in A and B. And then our result will just be the maximum of the rank so far. So result is the maximum of either result or this new rank. And again, at the end, we'll just return our result. Okay, so this network rank for cities, we need to create this function. Okay, so now we have our basic framework. We're taking our roads and we're converting that into a graph that we can use. Then we're just going through every pair of cities, A and this should be B. So for every pair of cities, which is exactly what it tells us to do, we're going to calculate the network rank for that pair. And if that rank is greater than our current result, we'll just replace our result with this new rank. All right, now we do need to create our function here for calculating the network rank. So this will take two cities, A and B. Now it tells us over here that the network rank, let's see what that, it's defined as the total number of directly connected roads to either city. And if a road is directly connected to both cities, it is only counted once. So let's just make sure that this is doing what we think it's doing. I think it's the sum of the two roads or the two cities, but let's just double check here. So in this example, we have 0, 1, 2, and 3. And it looks like 0 has 1, 2 directly connected roads, and 1 has 1, 2, 3 directly connected roads, but this road is shared. So it looks like we have 1, 2, 3, 4 total, and our result is 4, yes. So it's the sum of the directly connected roads of the two cities in our pair, but we only count a road that's connecting those two cities together once. We don't count it twice. So for this, let's just do this the simple way. Let's just sum the total for each city, and then if one city is connected to the other, we can just subtract 1 so we don't double count. All right, so in this case, our rank will just be, that's going to be the length. So that's the number of cities connected to graph for city A. So graph for city A will return a set of all the connected cities, and the length will just tell us how many roads there are. So the length of graph B. All right, so now we have summed the number of roads directly connecting to city A and the number of roads directly connected to city B, but we might need to subtract 1 if A and B are directly connected to each other. So I could just do this. If A is in graph of B, that means A and B are directly connected. If that's the case, then we have to subtract 1. So our rank minus equals 1. At the end, we just return our rank. Okay, I think this looks pretty good. We've broken this out into sort of 3 pieces. First piece is build our graph. Second piece is go through every pairing. And the third piece is this helper function that will calculate the rank for every pairing, or for a pairing of two cities. At the end, we return our result. All right, let's see how this goes. It looks like it's working. Let's see if we pass. And we pass. All right, and let's see how we do. We actually do pretty well. So we beat 87% for runtime and 15% for memory. So yeah, that's not too bad. Now we could jump back here and fix this up a little bit, or I shouldn't say fix this up, because this is actually pretty clean, pretty well organized. I actually like this the way it is. However, if we want this to run faster, we could do certain things. Like we could, instead of having this be a function, we could embed it in here so it doesn't have to do a separate function call every time it goes through this loop. That's one thing we could do. We might try things like sorting our cities and only like use the top cities that have the most connections to them. And that way we can sort of early out when we start getting to cities that have lower numbers of connections. We could maybe do something like that, but sorting the cities by the number of connections might actually take more time than just going through all the cities. It's unclear. So I'm pretty happy with this. I'd actually say I'd probably wrap it up here, but just to see if we can get a little bit of a boost, let's move this function into our loop here, just to see if this function call makes that much of a difference. All right. So instead of calling this rank, I'll just do this. Right. Okay, so now instead of our helper function, we're just doing this directly. Now one other thing we could do, now notice we're calling this length of A and B multiple times. Every time we go through this loop, we're going to be calling this a length function. We might actually want to just go through our list of cities once, calling the length function and then caching that out somewhere. So have another list of, or maybe a dictionary of city to length, but we'll see. Let's see if this works first. It still works. Let's see if this gives us any kind of boost. And doesn't actually. It does worse. So we went from an 87% down to 73%. Interesting. That surprises me. So we did far worse by removing that function. All right, let's go back to our function then. Okay, the other two things that I can think of. One is that length thing we talked about. The other one is this max. So we can replace this max with our own calculation. Sometimes it's a little bit better. So result will equal result if the result is currently greater than our rank. Otherwise, we'll replace it with our rank. So this is doing the same thing that the max function does. We're just doing it our own. All right, result if result is greater than rank. Okay. Still works. Let's see if this gives us any kind of performance gain. And that does, surprisingly enough. That gets us to a 94% for runtime and a 15% for memory. So that's a huge win. I think I'm pretty happy with that. If you're interested, you can check this one out and try doing that length thing we talked about. So instead of calling length every time, you can go through the list once, store the length in a separate either array or dictionary. And that way, instead of calling length every time, you can just do a reference lookup for the city to length value. Okay, well that's it for me. Hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.